Hello, everyone. Welcome back to another episode of Tantra's Mantra, where we go behind and beyond the tech news headlines. I'm your host, Prakash Sangam, founder and principal at Tantra Analyst. Today, we are again focusing on Cadence. No, we are not talking about the EDA tools, and the other things that they're famous for, but more focus on their semiconductor and silicon business. They had their own hardware IP blocks for some time, but significantly expanded that with the acquisition of Tensilica in 2013. But more importantly, they seem to have started ramping up this business recently. They had a couple of interesting announcements in last couple of months. The most important one was system Chiplet, the one that they launched in collaboration with ARM. Chiplets, although had some initial setback, are gaining a lot of traction across the semiconductor industry, but the challenges still remain, in my view. Cadence also acquired this company called Secure IC last month. Secure IC provides embedded secure platforms, which I think fits very well with Cadence's semiconductor offerings. To talk about recent announcements as well as the larger semiconductor business of Cadence, we have with us today David Glasco, who is the VP of Compute Solutions Group at Cadence. David, welcome to the show.
Thank you, Prakash. Thank you for having me on your show.
Perfect. David, could you please tell our listeners about your background and role at Cadence?
Certainly. So before coming to Cadence, most of my experience was in silicon design.
Mm-hmm.
I started at some research organizations, went back to school at Stanford.
Uh-huh.
After that, I worked in a number of traditional silicon houses, a
Uh-huh.
bunch of small ones.
Mm-hmm.
Worked at NVIDIA for, I don't know, 12, 13 years on a number of their products.
Mm-hmm.
I spent some time in a couple different startups.
Mm-hmm.
I did lead at Tesla. I did lead the full self-driving SoC design effort.
Very well.
And prior coming to Cadence, I was at Amazon working on their one of the Kuiper 5G modem SoCs.
Mm-hmm.
I've been now at Cadence for almost 4 years.
Mm-hmm.
And again, this is kind of my first venture into IP development and IP sales.
Uh-huh.
It's different, but really kind of interesting and challenging at the same time.
Very nice. So, and as I said, the whole chiplet itself, I think that's a growing and interesting industry in semiconductors. So, I think that provides a lot of good opportunities. We'll talk about that a little bit. But more fundamentally, I mean, Cadence is known for its EDA tools, right? Electronic design automation tools. And you started to expand this silicon semiconductor portfolio. So, could you give us the overview of this business and how it has evolved over the years?
So, you're right that Cadence traditionally has been an EDA company, but you
Yeah.
may have noticed over the last few years it's kind of, rebranded or refocused on more what they call computational software.
Mm-hmm.
Under our, new CEO, Andrew Devgan, he's kind of expanded Cadence to really focus on areas where there is intense computational software requirements, right? So
Mm-hmm.
today it's now grown to include computational fluid dynamics,
Mm-hmm.
uh, digital twins. So
Yeah.
Cadence as a company is expanding into new areas, but all related to design, all related to compute intensive designs. And so
Uh-huh.
part of that again is helping its customers do what they need to do to be successful, and that kind of ties into what we're doing in the IP group
Mm-hmm.
uh, as we move forward.
Okay. And what are some of the target markets you're looking at specifically for this semiconductor IP business?
So probably about 2 years ago,
Mm-hmm.
the group was called IPG, the IP group, and it really was focused on just selling IPs.
Uh-huh.
Over the past year and a half, we've, Cadence brought in a new leader for the group,
Mm-hmm.
Boyd Phelps, who has a long history at Intel.
Mm-hmm.
And after long discussions about strategy, it was observed that a lot of the customers are really looking for more than just IP.
Mm-hmm.
And so we kind of refocused our effort not only to provide IP, but to start to help customers build out solutions
Mm-hmm.
to their needs. And so, we've renamed the group to Silicon Solutions Group, really focused on, delivering solutions to the customers.
Mm-hmm.
And, Cadence as a whole has always been focused on helping customers, succeed with their products.
Mm-hmm.
SSG, Silicon Solutions Group, isn't focused on delivering Cadence branded silicon, but yet helping customers deliver their silicon. So, you
Mm-hmm.
won't see Cadence branded silicon.
Yeah.
You'll see Cadence working on behalf of customers to help them, win in their spaces. So
Mm-hmm.
as we over the last year and a half, we've seen more and more new industries. Automotive is a great example of
Yeah.
traditional companies that have always acquired silicon from third parties now
Mm-hmm.
wanting to kind of follow the Tesla model and
Mm-hmm.
build their own silicon. But
Mm-hmm.
as you know, most of these automakers don't have a long history of silicon development, nor do they have the design teams.
Yeah.
So these are the type of customers, and aerospace and defense is a very similar situation, right? So we see a lot of
Mm-hmm.
these customers coming to Cadence, asking for help to build out the full solution. And
Mm-hmm.
part of that strategy, we acquired another company at the beginning of last year,
Mm-hmm.
Invictus, which is a design service house in Hyderabad.
Mm-hmm.
So that brings more design service and silicon, manufacturing capabilities to Cadence. So, Cadence can actually help customers all the way from, idea to silicon delivery. And it's very appealing to a lot of these new industries that just simply don't have the capability nor really want to build out the design teams to build their own silicon.
Yeah, and there is, the latest trend I would say is a lot of need for customization as well, right? Rather than just taking
Yes.
off the shelf. When it comes to automotive and defense that you mentioned, they don't want off the shelf rather than something that is custom made for them and that basically addresses their specific challenges and they're large enough scale to support that kind of a model, right?
Yes. I mean, you're absolutely right. They want to have some unique differentiation in their designs.
Mm-hmm.
But if you look at most SoCs designed today, most monolithic SoCs,
Yeah.
majority of the logic on there is third party IP that you just need as part of your system that you don't bring any unique value to implement that yourself. A good example is, ARM CPU clusters.
Mm-hmm.
You need them on your chip, but it takes a lot of engineering resources to do that. But
Yeah.
if I were to harden a CPU cluster, if you were to harden a CPU cluster, we'd end up with the same thing. And so
Correct.
that's one of the kind of the motivations for customers getting excited about chiplets. I mean, there's many
Mm-hmm.
reasons, but one of them is they look at a system and they think, wow, I could just focus on building my chiplet that has my secret sauce.
Correct.
Hopefully the market provides all the other building blocks. And now I have a significantly reduced, engineering effort to create a differentiated solution for my particular needs.
Okay, and we'll go into a little bit detail into the chiplets. So, with your renewed focus on semiconductor and solutions, what are the top markets that you said you're targeting? Automotive is one, air and defense.
Yes, it's really this. There's a couple different domains, right? There's the
Uh-huh.
what we call kind of physical AI domains. Any kind of moving vehicle. So it's automotive, robotics, drones.
Yeah.
So again,
Uh-huh.
it's a new industry where there's not a lot of silicon players, and there's a desire to have
Yeah.
uniqueness in designs. Aerospace and defense, they traditionally a lot of FPGA work, and now they see Cadence as a way to help them achieve their silicon goals. So really, it's
Yeah.
industries that don't have large design teams today that wanting to get into silicon design so they can create unique value in their markets, right?
Yeah, yeah, okay. And also, many of these industries, I mean, earlier the electronics or the semiconductor is more of a add-on, like if you take automotive, but now they are becoming central to their differentiation, right? I mean, if you take EV, it's kind of a smartphone on wheels, right? So, I know you take tier one OEMs, Mercedes Benz or BMW, their differentiation was their engine, and then the other things like the entertainment and others were add on which they were getting from their tier 1 providers, but now with EV the semiconductors becomes the differentiation for their products, right? So that's also putting a lot of focus on getting their own or customized semiconductor in their products.
Yeah, that's right. And not only, thinking about a particular product, remember a lot of these automakers have, a large number of different vehicle lines.
Yeah, tiers and yeah. Yeah.
Software verification is also a huge problem in the automotive world because traditionally
Uh-huh.
every computer, there's many computers even in a gas powered car, and they're all different,
Yeah.
right? And so that creates a lot of problems.
Yeah.
So now when they move to EV and they move to software defined vehicles,
Correct.
they want a solution that scales from their low end cars to their high end cars. That's all the same architecture,
Yeah.
and gives them some unique value. And they look at where, like you said, in the past it was, how good of an engine do you have in your car?
Yeah.
In the future it will be how good of a, what is the look and feel that that software provides and creates for the vehicle.
Yeah.
By having uniqueness in the silicon design, they can create, different looks and feels
Yeah.
from their low end to their high end cars.
Yeah. Yeah. So the system chiplet announcement that you had, that you work very closely with ARM, tell me about that.
So as we went down this path of building out chiplets, we decided that we really needed to be able to demonstrate, our capabilities and learn more about chiplets.
Mm-hmm.
ARM had just kind of started working on their chiplet system architecture spec, which I think they have released publicly
Mm-hmm.
now.
Yeah.
And so, we decided the best way to really build anything is to actually build it,
Mm-hmm.
right? So we decided that we'd build it's a fairly small implementation.
Yeah.
It has enough capabilities to focus on how two chiplets interact, how they come out of reset, how they boot up, how they authenticate each other, which is all part of the ARM chiplet system architecture spec.
Mm-hmm.
And then, to make that work, we put some other functionality on there, memory controllers, some CPU cores,
Mm-hmm.
to manage security, to manage safety.
Yeah.
And of course, this is all connected up through our UCIe controllers and PHYs. So it was really a vehicle to demonstrate capabilities to help us learn what it really meant to build out
Mm-hmm.
a multi-chiplet solution,
Mm-hmm.
and just make sure we had the resources and team. And it's always great to learn along the way so we can really deliver when the customers are asking for help.
Cool. So I was a little bit confused. What do you mean by system chiplet? Isn't it same as SoC? It's like a full functional block.
So if you look at the way chiplets are evolving, right,
Yeah.
there's kind of this, at one extreme, you can imagine eventually I'll have a system that has many chiplets and
Yeah.
they're all kind of decentralized.
Correct.
But today, the chiplet architectures are still pretty straightforward, three or four chiplets,
Mm-hmm.
where one of them is what we call kind of the system or a hub chiplet, right?
Yeah.
It's the chiplet that everything else connects to. It's the basic building block of a system.
Mm-hmm.
And so you may build out a system chiplet that has, say, your IO capability, your memory capability,
Mm-hmm.
some other special functionality, and into that you could plug a CPU chiplet or a GPU chiplet or an NPU chiplet
Mm-hmm.
to build out what type of system you like to build.
Mm-hmm.
So you're right that a system chiplet has a capability to boot,
Yeah.
and it typically has a CPU, enough CPUs to boot and manage the resources on that chiplet.
Yeah.
But it tends not to have the large, 16 cores, 32 cores, or big NPU or big GPUs, right? It really is just,
Mm-hmm.
think of it as the plumbing for the system, right? And then
Mm-hmm.
into that, you would plug your higher performance chiplets to give you whatever capabilities you like to build out in your system.
Okay. And you're looking to utilize this to build your own larger multi-chiplet solutions for your customers, or this is like for other players to use and build their own products. How are you positioning this, or this just a trial for you to test out your computers and show what you can do and look at evolving it further?
It's some of both, right? It,
Okay.
it, it allows us to demonstrate our capability, but more importantly, it's kind of a building block for customers to come and start to think about and reason about what they would like in a system chiplet.
Mm-hmm.
And so many, the current engagements we have with customers kind of along those lines. Okay, we want a system chiplet, but we want these special functions put into the system chiplet for our unique domain.
Mm-hmm.
Then eventually we want an AI chiplet or an ARM GPU chiplet, or build upon one of the ARM compute subsystem.
Mm-hmm.
Have a chiplet built around that. So it really is, it gives us a good starting point to start to talk to customers about what they need to build, because remember that
Mm-hmm.
these customers don't have a lot of silicon experience, so
Yeah.
they also come asking for some architectural advice or support
Okay.
to helping think through how they would build out a system.
Okay. If I get it correctly, so it's basically kind of a starting point for you guys to get into this solution kind of a business wherein, based on what the customers are looking for, you will build this into different solutions for different markets or different functions, integrating different parts.
Yeah.
This chiplet could basically form some other functional chipset as well, right?
Yes.
Am I getting it right? Or yeah,
Right. And so, to your question a minute ago about, how is a chiplet different than an SoC?
yeah,
So the other thing, the chiplet has to work with other chiplets. So there's
correct,
this layer of functionality that each chiplet requires to enable them to implement
yeah,
what is specified in the ARM chiplet system architecture spec.
yeah.
So that's kind of one of these foundational pieces of logic that we're working to fill out that we would use in every chiplet that we build, and then prevents the customers from having to become chiplet experts, where they can then focus on their unique IP contributions.
Okay. Yeah, the reason I'm asking is usually the use of chiplet is it's kind of a specific fixed function chiplet that you put on when building a solutions, right? Like how EMD is doing, how Intel is doing. But you're saying the system chiplet is more of a starting point rather than an add-on, the way you are looking at it.
Correct. And also remember that all the big players you mentioned
Yeah.
tend to build kind of proprietary chiplets, right?
Yeah.
They have a reason for building the set of chiplets they build, which
Uh-huh.
sometimes is somewhat different than like what an automaker would want, right? And so in the world we're in, it's all ARM compliant chiplets, to build out in an ARM ecosystem.
Uh-huh.
For the bigger players, everything's internal, and they're just kind of using chiplets often to have a little bit of flexibility, but to also just get more silicon
Yeah.
in their solution.
And how's the traction been working with customers on building solutions for them?
There's a lot of customers are interested in chiplets. Chiplets. It wasn't too long ago where chiplets was really just a buzzword. It's
Yeah.
pretty surprising how fast it is gaining momentum.
Yeah.
And so I think we believe, in 2025 we'll start to see some major, announcements of, new players getting into silicon through chiplets.
Mm-hmm.
And I think that will be the momentum that starts, opens the floodgates.
Oh, cool.
Because again, it's these customers don't have experience with silicon, so oftentimes they're very cautious.
Yeah, of
Um,
course. And I agree. I mean, there's a lot of buzz, and but there is some realization as well in terms of implementing it, not just the buzz. And of course, there are initial setback on implementing system chiplet because it's still very complex. Because you might be coming from different vendors, they might be on different nodes, and so on, right? So, are you guys doing anything specific in terms of addressing some of those challenges in terms of utilizing chiplets itself?
I think in the first generation or two,
Mm-hmm.
most customers building chiplets will want to come to one design partner to build out
Yeah.
all their chiplets. Right? We're still a ways away from you being able to buy a chiplet from supplier A, another one from supplier B, and then going and building your own package.
Yeah.
So we're still kind of, it's customers come to us saying we want one throat to choke, right? We want someone to build
Yeah.
the chiplets, package the chiplets, and deliver me the tested complete solution.
Yeah.
So a lot, so yeah, there is a lot of challenges, but I think it's being managed right now by just saying, let's just have one supplier.
Mhm.
In the future, that'll slowly start to grow. You'll start to see solutions that have chiplets from different foundries,
Mhm.
chiplets, different processes.
Correct.
You'll start to see eventually, I'm not sure how long, in a few years, where you could then, okay, well, let's go buy a chiplet from company A and bring that into our solution as
Yeah.
we build out for a customer.
Yeah. When you talk to the foundry players, I mean, that's actually kind of the vision they are working towards. That you could bring different chiplets from different vendors and then kind of integrate all in a single package for the users to use it as a solution, right? I mean, but I agree that it's still a little bit away from where we are today. Tell me about this secure IC acquisition. I think it kind of fits very well with your offerings as well, right? In terms of IP blocks and so on.
Right. So
Yeah.
security is becoming very important.
Mm-hmm.
You know, I think we're at the point now where every silicon design has some amount of security.
Yeah.
Secure boot. Are you really running the
Correct.
software you think you're running?
Yeah.
And that's a change from not too many years ago, where only there is a small number of consumer devices like my Alexa, I
Yeah.
worried about security on.
Yeah.
But we're at the point now where security is in everything.
Mm-hmm.
And we spend a lot of time looking at all the various options, and found Secure IC to be a great engineering organization with a great product line,
Mm-hmm.
with a culture that very compliant, compatible to Cadence's culture. And so we
Mm-hmm.
went through the acquisition process, and we're very happy with what they have to offer. Right, not only do they have the traditional, what they call Securizer, which is their integrated security solutions.
Mm-hmm.
For they have a number of different products in that space, but they
Mm-hmm.
also do a lot of end-to-end security evaluation,
Mm-hmm.
and they do a lot of support in helping others reach certification. Right, so then they're not only building out security IP, they're really an expert in security. So we're very happy to have them, join Cadence,
Mm-hmm.
and we hope the deal closes relatively soon.
So, and how you're looking to utilize that IP in your offerings?
So Chiplets, think about it. So Chiplets not only has the traditional security worries, but if you build a multi-chiplet solution, there's
Yeah.
this notion of authenticating the other chiplets you're talking to, right? Are you really talking to the chiplet you think you're talking to?
Yep.
So now security is central in every chiplet, and
Mm-hmm.
part of the chiplet system architecture spec is that security layer, right? So how do
Mm-hmm.
I know who I'm talking to? Is it really who I'm talking to? Am I running the right software? So it'll become more prevalent in this chiplet world than even today in the monolithic solution. So
Mm-hmm.
we not only will offer it as a standalone IP for those wishing to build their own silicon solution,
Mm-hmm.
but we will make it kind of an integral part of our chiplet story,
Mm-hmm.
and an integral part of kind of this what we call this chiplet framework, that low layer hardware software that manages all the chiplet interoperability and interactions, especially around security.
So basically, you can integrate with all of your chipsets for sure, but you'll also offer it as separate security IP blocks if anybody wants to use it, right?
Yeah, exactly. I mean, Cadence will still continue to grow our IP business and support, individual IP licensing as we've always done, because we
Yeah.
have a lot of our, great customers still, they do their own silicon, right? They have very large silicon teams. So,
Yeah.
when we're growing into this space, we're helping new entrants into silicon build it out. And so.
Yeah. Is that kind of competing with your own customers, not only on the silicon IP side, but also on your EDA business side? How are you managing that dynamics?
So remember that we're not building, Cadence branded silicon, right?
Yeah.
You'll never be able to come to Cadence and buy a chiplet off
Correct.
the shelf.
Yeah.
We're just helping our existing customers achieve their goals.
Mm-hmm.
We don't see it, really as competing with our other customers. We see it more as helping our current customers, achieve their goals, which they were going to build, and we just want to make it more successful for them.
Okay. But at some point of time, I mean, those customers will compete with your other customers at the same level. But I get the point. Yeah.
You can kind of ask the same question on just the EDA tools, right?
Yeah.
If I give you a superior EDA tool flow than your competitor gets from our competitor,
Yeah.
am I really competing with other customers trying to compete with you? No, I'm giving you a better solution
Yeah.
that's available to everybody.
Good. So, how is AI proliferation changing all of this game? I think chiplets could be one good way to get into that game from you guys, right?
So we have, so I guess there's a couple different ways that
Hmm.
I can answer the question. One,
Yeah.
AI accelerators, right? So we
Yeah.
see we see pretty much everything being built this day has some form of AI acceleration.
Of course.
We have a strong, AI accelerator product line called Neo,
Mm-hmm.
which we see as a great foundation for building out a AI accelerator chiplet.
Mm-hmm.
Right, our accelerator has multi-core capabilities, so you can build a four-core, eight-core, AI accelerator with fairly high performance,
Mm-hmm.
and help customers build that type of chiplet. And so we see, because of the proliferation of AI,
Mm-hmm.
every chiplet, every solution has AI today,
Of course.
right?
Yeah. Yeah.
And so we'll just see more and more AI in every solution that we see built.
And the accelerators are going to the same markets that you've traditionally been playing.
Yeah, I mean, it's, if you go back to the notion of physical AI,
Yeah.
robotics, drones,
Correct.
automobiles,
Yeah.
they're all about reasoning about the environment, which has, AI
Hmm.
requirements, and even audio processing. Any chiplet or piece of silicon that interacts with the world around it
Yeah.
is a perfect candidate for AI.
Yeah, of course. Yeah. And I mean, all of semiconductor is only on the ARM side, not in x86. Of course, your EAD tools support x86. Is that by design, or is that where you see the opportunity, or?
Well, clearly, ARM is the prevalent solution for those wishing to license our CPUs. Right,
Mm-hmm.
you can't really license an x86 CPU today.
Yeah.
ARM, is in almost all the designs that go out.
Yeah.
Has ARM CPUs, and
Yeah.
so just for it is the leader, and we also believe the ARM specifications, like the chiplet system architecture, will drive the chiplet ecosystem. And
Mm-hmm.
so if you step back and look, ARM really going heavily into chiplets is really what will make chiplets successful.
Of course. Yeah.
Right? And so
Yeah, especially,
it
yeah, the interoperable open
exactly
chiplets, right?
right,
Yeah.
right.
And any views on new ISA like Risk 5?
I think if you look back, every SoC ever designed has some number of smaller embedded CPUs
Uh-huh.
doing various householding. And I remember when I was back at NVIDIA, they had their own unique, proprietary ISA and core to do that kind of work. I think one thing that RISC-V does is it kind of gives people a standardization at kind of that small embedded core if they want to have deeply embedded
Yeah.
CPUs.
Yeah.
It's really hard to compete with the ARM software ecosystem.
Yeah, of course.
When
Yeah.
you start talking about a new ISA is nice, but if you don't have a very strong software ecosystem, it doesn't do much for you.
Of course. Yeah.
And so that's why, RISC-V has a space in the deeply embedded where you're not exposing it to your customers
Mm-hmm.
and you kind of control the software.
Yeah, that's changing a little bit though, especially with the things happening with ARM and geopolitics and China being keenly focused on it because it's open architecture, right? So yeah,
Right.
be interesting to see how that develops. But you currently are steadfastly focused on ARM right now, then.
Yes.
Okay. And looking ahead, how is your semiconductor roadmap shaping up? What are the dimensions and directions you are looking to evolve this?
So, we'll continue to grow our traditional IP business, our, memory controllers, our interface controllers,
Mm-hmm.
our AI accelerators, and of course our, Tensilica
Yeah.
DSPs and embedded cores. So
Uh-huh.
that business will continue to grow. That is by far our biggest business today.
Mm-hmm.
But we see a growing space in helping customers achieve their silicon ambitions and
Mm-hmm.
really around chiplets. And so we see, over this year, we expect, to get a few customer wins to help them build out their chiplet solution.
Mm-hmm.
And we see that kind of accelerating over time.
You're looking to integrate your IP blocks into the chiplets and making bigger, larger solutions as such.
Yeah, I mean, based on our customer needs, right? So if you look at any large, scale chiplet, there'll be a lot of memory, a lot of I/O, a lot of accelerators.
Yeah,
There's a lot of need. Think of it. A chiplet is really nothing more than a platform to hold your IP.
correct. Yeah.
And so if you don't have good IP, you don't have a good chiplet story. So we continue to focus on having best in class IP, and the chiplets are just a way to really accelerate customers' time to market and reduce their engineering efforts to let them realize their silicon ambitions.
All right. Yeah. I mean, that's a good way to end. Thanks for all the insights, and thank you very much for coming over to Tantra's Mantra, David.
Thank you for having me on. I enjoyed it.
Yeah. So, folks, that's all we have for now. Hope you found this discussion informative and useful. If so, please hit like and subscribe to the podcast on whatever platform you're listening this on. I'll be back soon with another episode, putting light on another interesting tech subject. Bye bye for now.